Welcome back to my channel Kishore Sir Ki Pathshala. We were doing chapter Work and Energy 9 Cbse. Let's see part 4 today. We all know how energy is important for all of us. Life is impossible without energy. You cannot think life without energy. Right? The demand for energy is ever increasing for humans. Plants prepare their food to get energy, as you know. The sun is the biggest natural source of energy for all of us. Many of the energy sources for humans are derived from sun itself. Okay, so whatever energy we get from sun, and many other sources are also there. Okay, the food what we eat, we get energy for our body. Okay, so energy is the main constituent. Okay, the main requirement. So we can also get energy from other sources. What are these sources? These sources are the nuclei of atom, that is the atomic energy. From that also we can get the energy, right? Okay, from the interior of the earth, right? The temperature is high. So from there also we can get the energy. The solar source is there, that we are getting the energy from the sun. Okay, the tidal energy is there. Okay, and the wind energy is there. From all these sources we can get the energy, and we know that energy is very crucial part in our life. To run all the gadgets we require electricity, right? So that we can term this as energy. Now let's see energy in terms of physics, that is in science. So the word energy is often used in a day-to-day life we use. In science, what we need to give it a definite and precise meaning. Okay, so let us consider the following example. Let's see a few examples for understanding. When a fast moving cricket ball hits a stationary wicket is there, and if it hits the stationary wickets, the cricket ball, then what will happen with the cricket ball? Let's see. Okay, so the wicket is thrown away, right? When when raised hammer falls on a nail placed on a piece of wood. See, a piece of wood is there. Okay, and we have a hammer, right? And that hammer, we put it on a nail, right? It drives the nail inside. Ah, when we hammer it, the nail will be there inside the plank. The object acquires through different means the capability of doing work, right? What happens is that the object, it acquires the capacity of doing the work. So what we can define about the energy? An object having the capability to do work is said to possess energy, right? The object which does the work loses energy. The object which does the work loses energy, and the object on which the work is done, okay, that will gain the energy. So a very simple definition we can have: an object having a capability to do work is said to possess energy. The object which does the work loses the energy, and the object on which the work is done gains the energy. So now let's see, how does the object with the energy do work, right? Let's see how it does the work. An object that possesses energy can exert a force on another object. It can exert a force on another object, right? Suppose here, if you see here, so this is the object, right? So it has got energy. So when this pendulum hit another pendulum, right? Now see this another ball it hits, then what will happen is that the energy is transferred from this ball to this the next one. Okay, when this happens, the energy is transferred from the former first object to the second object. From the first object, it's transferred to the second object when the collision takes place. The second object may move as it receives the energy. As this object receives the energy, it moves and therefore do some work. What work it will do? It will show you the displacement. So thus the first object has the capacity to do work, right? The first object has the capacity to do work. This implies that any object that possesses energy can do work. Okay, so any object which has got energy can do work. So hammer was there. Okay, hammer possesses energy, so that can do work, right? A cricket ball, it hits the stump, so cricket ball possesses what? Energy, so it can do work. All right. Now let's see unit of energy. So we have seen unit of work, right? So let's see unit of energy. So what we see is that the energy possessed by an object is measured in the terms of the capacity of doing work, right? Of capacity of doing work. The unit of energy is therefore the same as that of work. Okay, what was for work? It was joule, right? So the unit of energy is same, and we have already defined joule. So 1 joule is the energy that required to do 1 joule of work, right? So what is a 1 joule of energy? That is required to do 1 joule of work. Sometimes a larger unit of energy is called as kilojoule is used. 1 kilojoule is nothing but it is 1000 joule. Okay, so we need to remember this. Then let's see different forms of energy. So we live in provided energy in many different forms, right? So various forms of energies are there. The various forms includes what? It includes the mechanical energy, that is nothing but my potential energy, and kinetic energy. There is a heat energy, and okay, there is a chemical energy, electrical energy, and light energy. So these are the different forms of energy what we come across. Now let's see one activity, a very nice beautiful activity. What we need to do? A very simple activity. We need to take a heavy ball, we need to take, right? Okay, now we need to drop it on a thick wet bed of sand. We need to take a bed of sand and we need to throw this ball. Okay, just like that we need to throw? No, we need not throw that ball like that. What we need to do? Throw this ball from the height of 25 centimeter first. Okay, so first what we'll do, 25 centimeters we will throw the ball. Then what does the ball creates? The ball will create a depression. See here, the ball creates a depression. Okay, now what we need to do, repeat this activity from the height of 50 centimeters, 1 meter, 50 centimeters, 1 meter, right, and 1.5 meters. Okay, and we need to check the depression created by this ball. Okay, so the ball will go inside, right, and it will create a depression. We need to measure the depression. Okay, you need to measure the depression. Ensure that all the depressions are distinctly visible. Mark the depression to indicate the height from which the ball was dropped. Okay, a very simple activity. Now let's see what are the observation. Compare their depths. Which one of them is the deepest? Yeah, student, what do you feel? Which one will be the deepest? Right? The one which is dropped from 25 centimeter or the one which is dropped from 1.5 meters? Absolutely right. We see that the deepest depression is created when the ball is dropped from the height of 1.5 meters. Right? So which one is the shallowest? Right? That will be 25 centimeters. Okay. Why this difference is there? Why this difference is there? Why one has created the deepest depression and why one has created the shallowest depression? As you all know that the mass of the ball remains constant. Then why this difference is there? The difference is because an object or a body possesses potential energy at a certain height. As the height increases, the potential energy possessed by the body also increases. More the height, more is the potential energy. Okay, more the height, more is the potential energy. Greater is the potential energy, greater is the kinetic energy. If the potential energy is greater, then the resultant kinetic energy will also be greater. So what we have learned from this activity? We have learned that height and potential energy has got a relationship. Right? Greater the height, greater is the potential energy. Okay. Greater the potential energy, greater is the kinetic energy. Student, I'm sure you have understood today's part, that is what is energy, what is the unit of energy, and how the relationship of height with potential energy is there. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala.